Hello everyone and welcome to another Maths tutorial video. Now I'll be discussing SPM clone 2005 Form 5 Chapter 2 Linear Law short question. Alright, let me read the question now. The variables x and y are related by the equation y equals to mx square, where m is a constant. Reduce the equation y equals to mx square to the linear form. Okay, that is for the question part A. Okay, let me read the question part B. The diagram shows the straight line obtained by plotting log 10y against log 10x. So this is the diagram, guys, of the graph. So from the diagram, they ask you to find the values of m and k. So this is the overall question. So I hope that you will attempt this question in the future. If you could manage to solve this question, well done. But if you can't solve this question, no worries. I'm going to show you the step-by-step working and the solutions now. So without further delay, let us start to discuss SPM Clone 2005 Form 5 Chapter 2 Linear Law short question now. Okay, before that, please like this video to show your support and subscribe to the channel for more upcoming mathematics tutorial videos in the future. Alright, let us start our discussion for the question part A. Okay, for the question part A, we need to come up with a linear form based on the non-linear form given by the question, which is y equals to mx square. So from here, let us continue. So to form the linear form, so what we're going to do is we're going to log both sides with respect to base 10. Okay, so let us continue. So as you see here, we have already logged both sides, where you have log y equals to log mx square, okay, with respect to base 10. Okay, it is understood, guys, if you don't write here 10 or if you want to write here 10, it's up to you, but this condition is only applied to base 10. Okay, other than that, you need to mention the base number. Okay, let us continue. Okay, so this log mx square, by applying the logarithm rule, you can break this into two components from the addition method, okay, where you have log m plus log x square, because when you combine this, it will become a multiplication of mx square. So I hope you understand what I mean. Okay, so the second working, you have log y is equals to log m plus with log x square. Okay, so this to the power, you can bring it in front. Okay, let us take a look at the next step. So from here, log y is equals to 2 log x plus with log m. Okay, I rearrange such a way that it satisfies the straight line equation form, which is y equals to mx plus c. Okay, how this equation can relate to y equals to mx plus c? Okay, let me show you the mapping now. Okay, so this is the y equals to mx plus c representation. So as you can see here, log y is represented by y, 2 is represented as the gradient, log x is represented as the x, and log m is represented as the c. Okay, in this case, c is the y-intercept. Okay, so therefore your final answer should be log y is equals to 2 log x plus log m. So this is your linear form. So let us continue to the question part B now. Alright, let us continue to discuss the question part B now. Okay, let me pull this paper up. Okay, since we have already obtained the linear form in question part A, so the next step what we need to do is we need to proceed to compare the gradient and y-intercept in the graph which is given by the question. Okay, so this is the oral question B, guys. Okay, within this question B, you have part 1 and part 2. So we're going to start with the part 1. Okay, in the part 1, we need to start with the y-intercept. Okay, since they ask us to find the value of m. Okay, so let us continue. So to find the y-intercept, what we're going to do, we're going to compare log m with the y-intercept given by the graph, okay, in the diagram. So in this case, where your log m is equals to -1, so this is your straight comparison. This comparison is from the linear form, and then this value is obtained from the diagram. So log m is equals to 1. Okay, remember, guys, this log is respect to base 10. Okay, to proceed to the next step, so what we do is, so we log this negative 1 with respect to base 10. So from here you get log m is equals to log 10 to the power of negative 1, because this negative 1, when you move it to the front, so log 10 will become 1. So negative 1 times it 1, you get back the original answer. Okay, so from here log m is equals to log 10 to the power of negative 1. So this log and log will cancel off. So you're only left with m is equals to 10 to the power of negative 1. So 10 to the power of negative 1 is also equals to 1 over 10. Okay, so this is your first answer. So where you get your m is equals to 1 over 10. Alright, let us discuss the question B part 2 now. Okay, let me turn to the next page. So please hold on for a moment. Okay, once you have already find the value for y-intercept, the only value which is left is we need to find the value of k, and we have to compare with the gradient value. Okay, so to find the k value, okay, we're literally comparing with the gradient value. So m is equals to y2 minus y1 divided with x2 minus x1. Okay, in this case, k minus negative 1 divided with 2 minus 0. Okay, so since in the early question we have already come up with a comparison that m is equals to 2, so we're going to substitute the 2 into the gradient value here. So 2 is equals to k plus 1 over 2. Okay, this 2 we're going to times with this 2 over here. So from here you get k plus 1 is equals to 4. So actually I rearrange the equation. So k plus 1 is equals to 4. So to find k, what you do, this one you move it over to the right hand side. So from here you should get your k is equals to 3. So this is your final answer. Alright, that is all for the step-by-step working and solution for this question. I hope you understand the full working that I've shown to you. If you like this video, please give your thumbs up. If you haven't subscribed to the channel, please subscribe to the channel and hit the bell icon for more upcoming mathematics tutorial videos in the future. And also not to forget to share this video. Thank you everyone for your support, and I'll see you in the next video.